Today we're looking into the progress that's been made recently with superconductors. How close are we to room temperature superconductors? Ambient pressure superconductors? And can we even get there theoretically? Let's dive in. I'm Ben, this is Physics or Bust. Let's deal with the last question first. Physicists just gave us some great news regarding superconductors. For years, physicists have debated whether room temperature superconductors were even possible. But earlier this year, researchers at Queen Mary University of London delivered some exciting and stunning news. They finished theoretical calculations regarding the upper limit of superconductors' critical temperature. Their theoretical analysis, based purely on universal physical constants, confirms that room temperature superconductivity is allowed by the rules of physics as we know them. They used constants like the electric charge, Planck's constant, the speed of light, and a whole lot of others to come to this conclusion. Their models showed that the theoretical limit for the superconducting critical temperature should be somewhere between 100 Kelvin and 1000 Kelvin. With room temperature around 300 K, that is well within reach. This doesn't mean that we know how to make a room temperature ambient pressure superconductor yet, but it does mean that we're not going snipe hunting. We'll dig into the physics in a minute, but first, if you like this video, you'd probably like this book. I've got a link in the description below. I do get a small commission, but it wouldn't cost you any extra. Superconductors are a material that, when cooled below a certain temperature and at a high enough pressure, have zero electric resistance. In normal wires, energy is lost as heat because of that resistance, but in superconductors, the current goes on forever. This happens because electrons form special pairs, called Cooper pairs, that glide through the atomic lattice without scattering. But here's the catch. Most superconductors only work when they're colder than Antarctica. Much colder. And keeping something that cold takes a lot of energy. Today, up to 10% of the energy generated in the US is lost during transmission. But imagine a grid where electricity flows without loss. Room temperature superconductors could slash energy waste in power lines, make maglev trains more affordable, revolutionize MRI machines, and supercharge the quantum computing field. And beyond just looking at energy, tech miniaturization and zero-heat electronics could shift what's possible with our electronics, including AI, data centers, and high-performance computing. And right now, progress in room temperature ambient pressure superconductors is accelerating. Where do you see superconductors being used in the future? Let me know in the comments below. Researchers at the University of Houston figured out a way to lock in a material's superconductivity and bring it back to ambient pressure using a process called pressure quench protocol. What they do is take a material at room temperature and apply pressure using a diamond anvil cell. Then cool the material to a specific low temperature, usually a cryogenic temperature like 4.2 Kelvin. Then while it's still at that really low temperature, they rapidly release the pressure. This makes a material that's usually only superconductive at high pressure keep its superconductivity even at ambient pressures. That's big because many superconductors only work under crushingly high pressure conditions. At Stanford and SLAC, researchers recently created nickelate thin films that are superconductive under no pressure. This is thanks to strain engineering, where they introduce external forces onto the material in order to change the electronic and structural format of the material. This is thanks to strain engineering, where they introduce external forces on the material in order to change the structural and electronic properties of the material to get the superconductivity that they want. Properties such as relatively high critical temperatures and near ambient pressures. We're not at room temperature and ambient pressure yet, but material engineering is getting closer and closer. When it comes to room temperature superconductors, you might remember a buzz that went around a few years ago in 2023 regarding a material called LK99. In mid-2023, a mysterious rock from a Korean lab set the physics world and the internet on fire. A room temperature, ambient pressure superconductor that was made from common materials in a lab oven. But because a material's superconductivity is a delicate dance between physics and chemistry, even a promising material can disappoint if its structure isn't just right. The researchers posted a video of a sample levitating over a magnet, which is a possible sign of the Meissner effect. And there was a whole lot of excitement. But then things started to unravel. Most replication attempts failed, the material wasn't showing true superconductivity, and the levitation? Probably more like ferromagnetism than actual superconductivity. By late summer, the majority of the scientific community was in one accord. LK99 was not superconductive. But here's the thing, the announcement still had an impact. It reminded the world just how powerful a room temperature, ambient pressure superconductor would be. So while LK99 did flop, its announcement brought more attention to the research so that others could really focus in and make some other breakthroughs. And each breakthrough gets us one step closer to a truly room temperature, ambient pressure superconductor. Imagine a world where every watt generated produces power instead of wasted heat, where your computer stays cold, where nationwide power grids run without losses, and where energy can be stored in magnetic fields for centuries. Room temperature ambient pressure superconductors wouldn't be just a better wire. It'd be a redefinition of what's possible. And the race to find them is, quite ironically, heating up fast. Superconductors might be the backbone of the next tech and power revolution. And we're not there yet, and unfortunately I can't answer how long until we get there, but at least science says that it is possible. So just like Thomas Edison found 1,000 ways not to make a light bulb before finding a way that worked, researchers are working on finding their 1,000 ways not to make a room temperature ambient pressure superconductor, until they find the one way that does work. They just have to find the right material and the right process to make it work. For more discussions on science and tech, remember to like and subscribe, and remember, keep asking questions. I'll see you on the next video.